Mars has captivated humanity for millennia. Its fiery hue, visible even to the naked eye, earned it the title of the Roman god of war. Today we know Mars as a planet of stark beauty and intriguing mysteries. It is our next-door neighbor in the vast cosmic expanse, a rocky world half the size of Earth. Its reddish surface, a result of iron oxide or rust, hints at a dynamic past. Mars holds the key to understanding our own planet's evolution and the potential for life beyond Earth. Telescopes reveal polar ice caps that expand and shrink with the seasons. They show us dust storms that can engulf the entire planet. These observations tell a tale of a once active world, perhaps more similar to our own than we realize. The allure of Mars lies not just in its alien beauty but also in its potential. Could life have existed on Mars billions of years ago when it was warmer and wetter? Could it exist today, hidden beneath the surface? These questions drive our relentless exploration of the red planet. Today, Mars is a frigid desert, its atmosphere thin and unbreathable. Yet, geological formations tell a different story. Vast canyons like Valles Marineris dwarf the Grand Canyon, hinting at powerful forces that once shaped the Martian landscape. Dried riverbeds and ancient lake beds whisper tales of a time when liquid water flowed freely on Mars. These features suggest a warmer, wetter past, perhaps even an environment capable of supporting life. The presence of water is crucial, as we know it is essential for life as we understand it. The Curiosity rover has found evidence of organic molecules, the building blocks of life, further fueling our curiosity. Mars's thin atmosphere, composed primarily of carbon dioxide, offers little protection from the sun's radiation. Temperatures fluctuate wildly, plummeting to -200 degrees Fahrenheit at night. The lack of a substantial atmosphere also means liquid water cannot exist on the surface for long. The search for life, past or present, is at the heart of our fascination with Mars. While we haven't found definitive proof of life, tantalizing clues keep us searching. The presence of methane in the Martian atmosphere, a gas often associated with biological processes, is particularly intriguing. Scientists are also studying Martian meteorites, fragments of rock blasted from Mars that landed on Earth. Some of these meteorites contain structures that resemble fossilized microbes, though their origin remains a subject of debate. The possibility, however remote, that these structures represent evidence of past life on Mars is a powerful motivator. The search for life on Mars is more than just a quest for alien organisms, it's a quest to understand the very nature of life itself. If we find evidence of life on Mars, it would suggest that life is not a fluke confined to Earth, but rather a process that could emerge on other planets with the right conditions. Since the 1960s, we've sent robotic emissaries to Mars, each mission building upon the last. Orbiters like Mars Reconnaissance Orbiter provide stunning high-resolution images of the surface, mapping the planet in unprecedented detail. Landers like InSight probe the planet's interior, listening for Marsquakes that reveal secrets of its structure. The Curiosity and Perseverance rovers are our eyes and hands on the surface. They traverse the Martian landscape, analyzing rocks, drilling into the soil, and even testing technologies for future human missions. These robotic explorers are our scouts, paving the way for human exploration. Each mission brings us closer to answering fundamental questions. What is the history of water on Mars? Did life ever exist there? And what can Mars teach us about the evolution of planets, including our own? The discovery of even the simplest life form on Mars would be a momentous occasion. It would fundamentally alter our understanding of our place in the cosmos. Now, imagine the implications if we find that life arose independently on both Earth and Mars. Such a discovery would suggest that life is not a cosmic accident, but rather a natural consequence of the laws of physics and chemistry. It would mean that the universe could be teeming with life, waiting to be discovered. The search for a second genesis, a second origin of life, is a driving force behind our exploration of Mars. The possibility of finding extant life, life that exists on Mars today, is even more tantalizing. While the surface of Mars is harsh and unforgiving, there could be environments beneath the surface where life might persist. Subsurface aquifers, sheltered from the radiation and extreme temperatures, could harbor microorganisms. Looking beyond the scientific, Mars represents a new frontier for humanity. The idea of establishing a permanent human presence on Mars has captivated our imaginations for decades. It represents the next giant leap for humankind, a testament to our spirit of exploration and our desire to push the boundaries of what's possible. However, colonizing Mars is a monumental undertaking. The challenges are immense, from developing sustainable life support systems to protecting colonists from radiation to producing food and resources in a harsh and unforgiving environment. We must develop new technologies, overcome engineering hurdles, and ensure the psychological well-being of those who dare to call Mars home. Despite the challenges, the potential rewards of a Martian colony are significant. It would provide a backup for humanity in the event of a catastrophic event on Earth. It would offer access to vast resources and opportunities for scientific discovery. And it would serve as a stepping stone for further exploration of our solar system and beyond. The exploration of Mars is not just about rocks and robots or even the search for life. It's about us. It's about understanding our place in the universe and the challenges we face as a species. By studying Mars, we learn about climate change, resource management, and the delicate balance that makes life on Earth possible. The lessons we learn from exploring Mars could help us address pressing problems on our own planet. Perhaps the most profound impact of Mars exploration is its ability to inspire. Images from Mars rovers, tales of daring missions, and the prospect of humans walking on another planet ignite our imaginations. They remind us that we are capable of extraordinary things when we work together towards a common goal. This sense of wonder and inspiration is crucial, especially for younger generations. They will inherit the challenges and opportunities of the future by fostering a love of science, technology, engineering, and math, STEM. We empower them to become the next generation of explorers, innovators, and problem solvers. Mars, once a distant red dot in the night sky, is now a world we are actively exploring and learning from. It is a place of stark beauty, scientific intrigue, and boundless possibilities. The journey to Mars is a journey of discovery, a testament to human ingenuity, and a source of inspiration for generations to come. As we venture further into the cosmos, Mars beckons us to unravel its secrets, to push the boundaries of human knowledge, and to embrace the challenges and rewards of exploring our solar system and beyond. The red planet awaits, and the future of space exploration is bright.